In addition to the monitor-only operation mode, the MDC controller can also use the RS485 communication network to control the speed of the fans in the fan array. When monitor and control mode is selected, the MDC controller broadcasts a message to all fans in the array that changes the source of set value from the analog input to RS485. There are a number of options available in monitor and control mode: 0 to 10 volt control input, keypad, Modbus command, or a combination of control inputs. When in monitor and control mode, there are several wiring options, and the graphic shown is the terminal connection layout for the MDC controller. If an external power supply is to be used, the two power terminals on the left can accept a voltage between 10 and 48 volt DC. Next to these are the control input terminals. There's a 10 volt DC regulated output for use with a potentiometer. There's a control signal input. There is a 0 volt DC ground reference and an output to provide power for a pressure transducer. The next block of terminals are for fan network communications. RSA and RSB are for data transmission and reception. The ground should be connected to all devices in the network, and the 10 volt DC input is for when the MDC is being powered from the fans in the array. There's an alarm relay which can be activated by programming the MDC to recognize a fault condition, and network terminals to receive commands and transmit data to higher level control systems. If the MDC is being powered using an external DC voltage supply, the plus 10 volt DC connection to the power output terminals from the fans in the array should not be used. The controller should either be powered using an external power supply or powered from the DC fan output terminals, but not both at the same time, as this may cause damage to the controller and the fan control circuit. It is possible to use a pressure transducer with the MDC controller to calculate the volume flow passing through a fan array or to measure the pressure difference across it. In either case, the MDC offers some flexibility in how the feedback from the pressure transducer can be read. When 0 to 10 volt monitor and control mode is selected, the MDC will convert the signal supplied to the control input terminal into a broadcast Modbus command to vary the speed of the fans in the array. These terminals can also be used for volume flow or pressure differential measurement. However, as there is only one control input terminal, it is not possible to have both functions at the same time. To overcome this issue, it is possible to connect the output of the pressure transducer to the control input of the fan and configure the MDC controller to interrogate the fan array for the sensor feedback signal. With Modbus Lite fan motors, the controller can interrogate the register that reads the voltage level from analog input 1. For fan motors with full Modbus functionality, the user can choose to read from either the analog input 1 I/O1 terminal or analog input 2 I/O2 terminal. By connecting the sensor like this, the controller converts the 0 to 10 volt control signal input into a Modbus speed command that is sent through the RS485 network to the fan, whilst at the same time reading the Modbus register that reports the transducer feedback signal. In the next example, we will configure the MDC controller to respond to a 0 to 10 volt control signal input, convert the analog signal into a RS485 speed command, and read the sensor output of the transducer from the Modbus register that monitors control input A-in-1 on the fan.
In this example, we are starting with the MDC in monitor only mode. Using the left arrow on the keypad takes you to the main menu. Operation mode can be selected by using the down arrow, and the right enter key will allow you to change the configuration. Use the down arrow to select monitor and control, and use the right key to confirm. At this point, if a pressure transducer has been installed at the control input of one of the fans in the array, or the control input of the MDC controller, the option Enabled should be chosen. If the pressure sensor option is chosen, the MDC will request input on a number of choices. Firstly, whether the output of the pressure transducer is installed at the fan analog input or brought out to the control input on the MDC controller. Whether volume flow or pressure measurement is required. What the measurement range of the sensor is, and the fan inlet ring K factor if volume flow measurement is chosen. In this case, the source of the sensor will be set to fan analog input 1 and will choose pressure differential, and the sensor we're using has a 0 to 2000 pascals range. The 0 to 10 volt option is the first option that's highlighted by default, and by selecting enter by pressing the right arrow fixes the operation mode. After a reset, the MDC controller searches for the pressure sensor inputs at the fan analog input. After a brief test run, the MDC controller has found that both fans in the network have a sensor connected to their analog inputs. The user is then given the option to confirm that this is correct. After a reset, the MDC will now control the fan array over the RS485 communication network by responding to the control signal at the 0 to 10 volts terminals on the MDC controller.
When keypad control mode is selected, the MDC will respond to a value that has been entered using the keypad on the front of the controller. In this mode, it is also possible to connect a pressure transducer to the MDC controller to calculate the volume flow or measure the pressure differential across the fan array.
For keypad control, use the left arrow to access the main menu. Operation mode should be selected and confirmed to change the configuration. Select Monitor Control and use the right key to confirm. At this point, if a pressure transducer has been installed in the system, the option Enabled should be chosen. The source of the sensor signal should be set to the appropriate source. In this example, it's fan analog input 1 terminal. The measurement parameters should be selected. In this example, we're selecting volume flow. The pressure range of the transducer is 0 to 2000 pascals and the K factor of the inlet ring is 76. Once the measurement mode is selected, the control option keypad should be chosen, after which the controller performs a reset and enters sensor search mode. If all sensors are correct, then the user can accept the sensor mapping. Once the reset is complete, the MDC controller is gone into the monitor only mode, and to set the speed of the fan you need to go back to the main menu. Set speed should be chosen and the speed can be dialed up in percentage terms.
When Modbus control mode is selected, the MDC will respond to a client request made to the server terminals over an RS485 RTU network. In this mode, it is also possible to connect a pressure transducer to calculate volume flow or measure the pressure differential across the fan array. Choosing this option allows the user to view the measured flow or pressure on the MDC display screen. And in addition to this, the measured performance of the fan array can be interrogated by a client device or a building management system.
For Modbus control, I will be using ModScan software to write to the holding register that sets the speed of the fan array in terms of percentage. I will also be reading from the holding registers to confirm the actual speed of the fans. To set up control via Modbus, use the left arrow on the keypad to take you to the main menu. Operation mode can be selected using the down arrow, and the right enter key will allow you to change the configuration. Use the down arrow to select monitor and control, and use the right arrow to confirm. At this point, if a pressure transducer has been installed at the control input of the MDC or at one of the fans in the array, the option Enabled should be chosen. In this case, we will not configure the MDC controller to read from a pressure transducer. Choose Operation Mode Modbus, after which the controller will perform a reset. After the reset, the controller will enter monitor mode, waiting for a command to be received at its server terminals. Using an external client connected to the server terminals on the MDC, the speed of the fans can be changed by sending a command to a holding register.
For this example, we will use holding register 4, which is the set speed of 0 to 100%. To verify the speed of the fans in the array, we can use holding registers CB08 and CB09, which will return the speed of the two fans in RPM. The first set point we'll choose is 25% of maximum speed. Once the fans have settled, we can read that fans 1 and 2 are operating at approximately 850 RPM. Next, we'll choose 50% of maximum speed. Again, once the fans have settled, we can read that both fans 1 and 2 are operating at approximately 1740 RPM. A list of the holding and input registers for monitoring and controlling the MDC via a Modbus network server terminals can be found in appendices D, E and F of the instruction manual. In monitor and control mode, the MDC allows the user to change the operating speed of the fans using a combination of the 0 to 10 volt control signal, keypad entry and BMS client request. When operated in this mode, the MDC will vary the speed of the fans in the array according to the latest instruction received.
In monitor and control mode, we can control the fan array via the MDC controller using multiple control inputs. By changing the configuration to respond to multiple control inputs, the controller will change the speed of the fans in the array according to the latest instruction received. Returning to the operation mode via the main menu, we can select Monitor and Control. The pressure transducer can be enabled and read at the fan analog input. We can choose volume flow, set the pressure range of the transducer from 0 to 2000 pascals and a K factor of the inlet ring to 76. The control mode can be set to multiple inputs, and in this case we will choose all three. After a reset, the controller will search and map the pressure sensor inputs at the analog input terminals on the fans. The user can then confirm that the number of sensor inputs found are correct and can be mapped into the controller memory. After another reset, the MDC will now control the fan array over the RS485 communication network. If I adjust the potentiometer, the fans will start to run. Should I wish to change the set speed of the fans using the keypad, I need to return to the main menu and set the fan speed. Finally, if I wish to change the speed of the fans by remotely sending a message from a building management system, I can send a Modbus command to the register that also sets the fan speed.